Hello guys, welcome to my YouTube channel. My name is Charan HR. I am from Sri Venkateswara College of Engineering. In this video, I will be discussing about fabrication process in VLSI. I hope it will be informative and helpful to all. Now I am starting with introduction. VLSI fabrication, the journey from design to the process. VLSI fabrication is a complex and interactive process. The transformation of design into a functional integrated circuit, it involves a series of steps and carefully manipulation materials. At the nanoscale, to create a transistor, interconnections and other components, we will use VLSI fabrications. Next, the VLSI fabrication. In that, the foundation of vapor preparations. Crystal growth. High purity silicon crystals are grown from molten silicon using the Czochralski process. Next is wafer sealing. The sealing of silicon crystals is sealed into a wafers, a typical 0.5 to 0.75 millimeter thickness. Next is polishing and cleaning. The wafers are polished or polished to a mirror like finishing and removing any imperfections and preparations from the process. Next step is photolithography. Definition of defining the circuit pattern. In that, photoresistive applications. A photosensitive material called as photoresistive is applied to the wafer surfaces. Next is exposure and development. The exposure and development is done by the wafering exposed to the ultraviolet rays or light through the mask containing the circuit pattern and sensitive hardening the photoresistive. Next is the pattern transfer. The unexposed photoresistive removed inactive behind the desired pattern of the wafer surface. Next, in VLSI fabrication, we are using thin film depositions or depositions like building the circuit layers. In that, first one is PVD, physical vapor depositions. In that, the materials are vaporized and deposited into the water surface, creating thin layers. Next is chemical vapor depositions. A gaseous precursors which are deposited to a thin films or filming the desired materials into the wafers. Next is atomic layer depositions. A highly controlled deposition technique are allowed to the precious of layer which are exposed to the thin layer depositions. These are the main important things which we are using in VLSI fabrications. In next is in VLSI fabrication, we are using etching technique for shaping the features. In that, the first type is drying etching. A plasma is used to chemically and physically remove materials, creating intricate patterns within the eye precisions. Next is wet etching. Chemical solutions are used for selective remove materials, creating features with less precisions. Next is deep reaction iron etching, that is DRIE. A highly unintrinsic or anisotropic etching technique that are allowed to create deep and narrow features. These are the main features which are involved in etching techniques. Next, we are using doping iron implementation, that is controlled electrical properties. In that, iron implementation. Iron are the specific elements that are implemented or implanted into the silicon wafers, that is altering the electrical properties. Next is diffusion. Deposit atomic diffusions into silicon waferings, creating a controlled concentration gradient. These two are many involved in dopants that are a silicon dopant or a iron dopant or a N dopant or P dopant. These are the materials which are semiconductor materials that are mainly used in MOSFETs for doping process and fabrication process also. Next is planarizations and polishing, ensuring of for smooth surface. In fabrication process, we want a smooth surface. That was we are using our purposed methods and benefits. The main purpose we are using for creating a smooth and uniform surface on for a subsequent process steps. We are using several different purposes for doing the planarization and polishing. Next, methods, which are the method mainly involved in fabrication process. That is chemical or chemical mechanical planarizations and polishing techniques. Next is benefits. What are the benefits from this polishingness? In the first one is improving uniformity, reducing defects and enhancing the device performances. This is the last slide which I am discussing about the packing and testing. In VLSI fabrications, we are using for testing process. For that, we are using protection and verification in the chips. In that, we are using packing. The chip is encapsulated in the protective packages, provided electrical connections and mechanical supports. Next is testing. The testing is very important for any VLSI fabrications. For the testing process, we are using the chip is subjected into a rigorous testing to the ensuring the functionalities and reliabilities. Next is quality controls. In quality controls, we are using a stick qualities control measured and implementations throughout the fabrication process, ensuring and the quality and it is yields. Next, the final discussion is about conclusion. Conclusion: the VLSI fabrication, we are using several different layers. That is packing or testing, fabrication process, which gives us the pure filamented polished surface for doing many fabrications like N diffusions, P diffusions, which are these are types are involved in the fabrication process. Thank you for watching this video. Please like, share and subscribe.